We're here, and this is the 2005 AIME 2 problem 9. Here's a view of this problem. For how many positive integers n less than or equal to 1000 is sine t plus I cosine t raised to the power of n equals sine nt plus I cosine nt true for all t? Okay, let's try to digest this problem. So if I know by de Moivre's theorem, however you pronounce it, cosine t plus I sine t will equal raised to the power of n is equal to cosine nt plus I sine nt, and the proof is actually pretty trivial by induction. Just some motivation by testing powers of n and then induction, and it's trivial. But this is not quite the Moivre's formula. We have the sines and cosines flipped over. So how can we modify this so we can apply the Moivre's theorem? Well, we can actually just write this as cosine pi over 2 minus t plus I sine pi over 2 minus t. Because sine pi over 2 minus t will equal cosine t, and then cosine pi over 2 minus t will be equal to sine t, and raise this raised to the power of n. Now we can apply the Moivre's formula to get cosine of n pi over 2 minus nt plus I sine n pi over 2 minus nt. This is good. And then now we know we want this to equal sine nt plus I cosine nt. Again, let's just get this in forms of cosine and sine so we can maybe pattern match. So this becomes cosine pi over 2 minus nt plus I sine pi over 2 minus nt. Okay, now two angles have the same sine and the same cosine. These things are interchangeable. These two things have the exact sines and cosines if they are a difference of 2 pi from each other, right? If and only if. So n pi over 2 minus nt minus pi over 2 minus nt is equal to 2 pi k for some integer k. Okay, great. Now what we need to do is we see the nt's cancel out. This becomes n minus 1 pi over 2 pi times n minus 1, and then this is equal to 2 pi k. Let's just do some algebra. N minus 1 is equal to 4 pi k over pi, which is equal to 4k, from which n is equal to 4k plus 1. So in other words, n is congruent to 1 modulo 4. Okay, now what do we need to do? Now we see all the n of this form satisfy. So all we need to do is we need to count how many of these are less than or equal to 1000. So for every n we can take k equals 0, 1, 2, all the way until 249, right? And then that gives us 250 values, and we are done.